Okay, everyone, I hope you're as excited as I am. Why? Well, because we're on the home stretch. We're up to number 6, save and load a trained model. So we've gone through all these steps here. We've seen how to improve our models with hyperparameter tuning. And let's say we're at a point where we've improved our model to the point that we're happy to either share that with one of our colleagues or something like that, or export it and save it and put it in one of our applications so that our customers might want to use it, might want to access its predictions, something along those lines. Essentially, we want to take our model that we've trained, we've got these results, export it to file, and so that we can import it and use it somewhere else rather than it just being within our Jupyter notebook. So let's create a heading, 6. We'll go saving and loading trained machine learning models. Beautiful. And there's 2 ways we can do this. So 2 ways to save and load machine learning models. First one we're going to cover is with Python's pickle module. And the second one is with the joblib module. So let's check out how we might do it with pickle. So the first thing is to import pickle. And if you're wondering what pickle is, you can go Python pickle. As always, if we're not sure what something is, we can search it up. So Python object serialization. So if you read this, the pickle module implements binary protocols for serializing and deserializing a Python object structure. Well, in our case, if you're wondering what a Python object structure is, in our case, a Python object is our model. So if we want to say, for example, save GS classifier, so say we're most happy with our grid search parameters model, so the random forest classifier we've trained with grid search. If we wanted to export that, this is our Python object. And that's what pickle can help us do. So let's do that. Let's see an example of how we might export our GSCLF, which is a Python object, to a pickle file. So save an existing model to file. Yes, please. And to do so, we're going to use pickle.dump. We're going to pass it the object we would like to save, in our case, GSCLF, our grid searched classifier. And then you can name it something here. So we need to use the open function, so Python's open function for dealing with input and output of files. And in our case, we're just going to go GS random forest model 1. Now you can get as creative as you like with these names. There might be some nomenclature that you decide upon with your team or something like that. That's what you use for your models. But in our case, I've just gone something nice and simple. And .pkl stands for pickle file. And we also pass, because we're writing a file, we pass the parameter wb for write binary. So if we hit Shift and Enter, beautiful, this is going to save our grid search model with this file name to our current working directory. So if we go up here, if we go gs random, oh, we've got 2 randoms in there. So gs random forest. So this is a random forest, really random. 1.pkl. And you can see there's some other model files here. So .pkl, this is one I tried just before. And this is another one we created right at the start where we were looking at a Scikit-learn workflow. And now, if you've exported a fair few of these models, you might want to put them in like a model file, like we've got our data in a data file. So this is just one way to tidy up the directory. But you can see the one we've just saved here. That's seconds ago. Now, if we come back, how would we load that in? Well, we can do it with pickle as well. So load a saved model. So we're going to go loaded pickle model equals pickle.load. Now the advantage here is that because we've saved a model to a pickle file, and because it's stored in our directory here, is that someone who wanted to use our model won't have to go through all of the training steps that we've done above. They can just access the model and be able to make predictions by loading it in. We could copy this file name here, but we're just going to type it in gs tab. We use tab autocomplete for that. And now because we're reading in a file, we pass in the parameter RB for read binary. Wonderful. So that's loaded in our saved model. Now the way to check it is we can make some predictions. So to see if this model, if it actually worked, if we saved it and we can use it to make predictions, well then we're in a good place. We want to do loaded pickle model.predict. Now, similar to how we made predictions before with our GSCLF, we're just going to run this exact same line here, but make predictions with our pickled model. Predict on the test data set. Wonderful. And then we'll call our evaluate preds function and compare it, the test labels, to the pickle y preds. What have we got here? Found input variables with inconsistent number of samples. I know what we've done. We've got a data mismatch here. What we'd have to do is, I believe, if we just comment out this line and recreate, we have to reinstantiate our train and test split. That's what we have to do. So maybe I'll just comment out these lines for the time being and run this cell. Come back down here. We load it in. So the mistake here, I believe, and maybe wrong, hit Shift Enter. There we go. Is that our X test had been instantiated somewhere above and we had to reinstantiate it so that it was reset back to the correct shape. And now the way we can know that this has gone through correctly is if we compare. So if we compare our original GSCLF predictions, so these values here, if we copy these are the original grid searched classifier metrics. So let's have a look. So this is our loaded models metrics. Accuracy 78.69, same. Precision 0.74, same. Recall 0.82, same. And F1 score 0.78, so the same. That means that our import, our saving our model and re-importing it, so loading it in, has worked correctly. And now again, these names here, you can change them to whatever you like. Same with the loaded variable names. But this is just a quick example of how you can use Pickle to quickly save one of your models to file and then load it back in at a later date if need be, and then make predictions using the exact same loaded model that get the exact same results as the model we originally saved. In the next video, we'll see how we can do the same thing, except this time using job lib.